Okay, so far in topic 6, we've looked at how to determine the angle sum of a polygon. So depending on how many sides the polygon has determines what the total sum of the angles will be inside the polygon. And we've talked about the exterior angles as well. Now we're going to get specific and we're going to start looking at some quadrilaterals. One type of quadrilateral that we have is called a kite. And most of us know what a kite is or what it looks like. If we attach a little tail on here, that would look like a kite. Okay, and so we define a kite as a quadrilateral, meaning it has 4 sides, but a quadrilateral with exactly 2 pairs of congruent adjacent sides. To be congruent means equal. We know that from previous topics. And to be adjacent means next to. So in a kite, these 2 sides that are next to each other, okay, those are congruent. That's one pair of congruent adjacent sides. Okay, and then we have a second pair. Got a pair down here. These 2 sides, see the 2 tick marks, that means those are congruent to each other. And so we have exactly 2 pairs of congruent adjacent sides. Okay, now I do realize that these 2 sides are adjacent to each other, but those are not the congruent pieces. Okay, it's these 2 that are adjacent and congruent at one end of the kite, and it's these 2 that are adjacent and congruent at the other end of the kite. Now this kite doesn't have to be going this way. The kite could go up this way as well. These would be adjacent to each other in the kite, and these 2 would be adjacent to each other in the kite. So the kite can be arranged differently, can lie differently, but these would be one pair of congruent sides. These would be the other pair of congruent adjacent sides. Okay, you can think of a kite as a pair of isosceles triangles. So if I break the kite into 2 separate pieces here, this triangle right here, if I drew a line there, and I make that triangle, because these sides are adjacent, this is an isosceles triangle. And keep in mind from topic 4, what do we know about an isosceles triangle? Well, one thing that we know is that if these are the congruent sides, then these 2 angles are congruent to each other as well. Those would be the base angles, and those would be congruent. We call this angle here, if these are the base angles, this was called the vertex angle. Okay, we've got a second isosceles triangle. Okay, this triangle down here is also an isosceles triangle because it has 2 congruent sides, and that would mean that these would be the base angles. These 2 angles would be congruent to each other, and this would be the vertex angle. So a kite actually has 2 vertex angles. You have one at this end of the kite, you have a vertex angle at that end of the kite. Now you'll notice here that since these 2 angles are congruent and these 2 angles are congruent, what does that tell us about the whole angle? Okay, if you look at the next diagram, it says the non-vertex angles. So if this was a vertex angle here, this was a vertex angle there, these 2 angles are the non-vertex angles, and they are congruent to each other. They're equal to each other. This had 1 tick mark, 2. If I add those together, I get the same total as I have down here. So these angles will always be congruent to each other in a kite. Okay, some more things about a kite that we know. Okay, it says, how are the diagonals of a kite related? Well, to make a diagonal, we've got a diagonal going here to the 2 non-vertex angles. We connect those, that's one diagonal. And then we also have a diagonal that goes between the 2 vertex angles. That's a diagonal. So a kite has 2 different diagonals. And some things that we know about a diagonal is that the diagonals form a perpendicular. Okay, they're going to cross at a right angle, so we have a 90-degree angle at the middle of that right there. Okay, and it also says that the diagonals of a kite are perpendicular to each other. There you see the 90-degree angle, and exactly one diagonal bisects the other. And you can look at the picture. It's the non-vertex angles. That's where we have a bisecting taking place. So this diagonal going this way in the picture has been bisected. You have the same distance at the top as you do the bottom. The diagonal that's between the 2 vertex angles, that does not bisect. It's only the one between the 2 non vertex angles that gets bisected. Okay, so only one diagonal is bisected. So let's go back so I can see my drawing here. It says, what is the measure of angle AXB? Well, this is point X right in here in the middle. That's missing off of the diagram. Okay, but the angle AXB would be A to X to B. Okay, that's that 90-degree angle right there. So you're going to want to write 90 degrees in your packet. Okay, then it also says if the distance from A to X, again this is X, if the distance from A to X here is 3.8, what would the distance be from A to C, this whole thing? Well, this is the diagonal that gets bisected, so if this is 3.8, this is also 3.8, and so to go from A all the way to C, I would have to add those together. Okay, line up your decimal point when you add. I get 7.6 units. Okay, and then lastly, it says if B to D, so B to D, this is the whole thing, is 10. So if this whole distance is 10, does B to X, does this equal 5? So in other words, is this diagonal from B to D, is it going to be cut in half? And the answer to that is no, because that is not the diagonal that was bisected. It's the other diagonal that was bisected. Okay, you turn the page. Got one more example I want to walk through. We're going to try it. It says we have quadrilateral. We have a quadrilateral PQRS, and they're telling us that it is a kite. Okay, we have a diagonal from Q to S. There's one diagonal from Q to S, and we have a diagonal from P to R. And we've got some measurements in there to help us out. It says, what is the measure of angle 1? Angle 1 is right here in the diagram. Angle 1 is where the two diagonals are intersecting. Okay, so what did we learn about the diagonals of a kite? They intersect at a right angle, so it would be 90 degrees. Okay, and I'm going to go up here and I'm going to put that in my diagram just in case I need it to answer another question. It's 90 degrees right here. Okay, it says, what is the measure of angle 2? Well, angle 2 is right here, that piece right there. Okay, and what I can see is that if this is 90 degrees right here, all of these are 90 degrees. So this angle right here is 90. I have a triangle right here. Okay, I know that's 90, I know that's 35, and I got to figure out the measure of angle 2. So if I add 90 plus 35, that's equal to 125. So these two angles together are adding up to 125, and if I subtract that from 180, I'm going to get 55 degrees. So angle 2 up here is 55 degrees. And then lastly, it wants to know what the measure of angle 3 is. Okay, I'm going to get rid of this. Angle 3 is right here. Okay, if you recall from an earlier diagram, if I were to take just this portion of the kite, this is an isosceles triangle. If I just look at that much of the kite, since these are the two adjacent sides that are congruent, what do we know about these two base angles? Well, those angles have to be equal to each other. So measure of angle 3 is 35 degrees. Okay, remember tick marks in the sides means that these two sides would be the same length. They'd be congruent to each other. These two sides have 2 tick marks. They'd be congruent to each other. So keep those things in mind as you begin to go through your worksheet and solve to find different variables inside your kite. You're going to find angle measures and you're going to be asked to find side lengths. Okay. Go ahead and start your worksheet and go ahead and answer the first side of the worksheet, I believe is all kites.